Hello friends, welcome to our channel all about electric vehicles. Please subscribe to our channel to know the best and overall things in every aspects about the electric vehicle calculation, commercially available electric vehicles or electric vehicle jobs. To know best overall things about electric vehicles, please subscribe to our channel. So today we are going to see the complete electric vehicle design part 1. So many people have idea to start a electric vehicle business, whether it may be a electric motorcycle or scooter or electric car or electric rickshaw or electric auto rickshaw or electric bus, electric truck, everything. So for that you need to know all these design details. Why I am saying this means, so these are all the details they will ask by the ARAI, 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 Automotive Research Organization of India. So in ARAI they will be asking all the design calculations for your electric vehicle to get approved. So only you can start your manufacturing process later. Without getting approval you cannot start the process. So this lecture completely teaches about the ARAI, what are the steps in ARAI process to get your vehicle, electric vehicle approval. So for producing the prototype, one single prototype, you need to calculate all the things needed for your vehicle. So this lecture completely covers all the design details and what are the steps involved for getting the ARAI approval also. So first thing in ARAI, for the two things we need ARAI approval. So why we need ARAI approval means for homologation process. So this is the process of testing any electric vehicle before it goes into production. So this process only certifies that this electric vehicle is safety to drive on Indian roads. So this is must. Another thing, for getting FAME subsidy. So FAME is nothing but this is the scheme produced by Indian government in the year 2015. Faster adoption and manufacture of hybrid and electric vehicles. So for getting the subsidy from the government, so you need your vehicle, the electric scooter or electric motorcycle bike should get ARAI approval, so that you will be using your electric vehicle for manufacturing and also for getting the FAME subsidy. You need this ARAI certification, it is must. So ARAI will be giving some 20,000 subsidy for each electric two-wheeler. So in this video I will be designing the electric motorcycle design. Electric motorcycle design part 1. So possibly I will be covering the power plant, battery and everything in this part 1 electric motorcycle design. So if you want to start your electric motorcycle manufacturing company, so it is very simple. Now, not only the corporate, and even a single person or 2 or 3 persons can start your own company, electric motorcycle company. You can start your own motorcycle company. So by knowing these design details, then with this design you can go and approach the ARAI. They will be approving that product and start your business accordingly. So for ARAI application, there are certain rules. So before that, you should make your team, 1 person or some 3 person. You make your team 3 persons. Minimum 3 person is good because teamwork. You can make a team and form a company. Know these electric motorcycle design details and get ARAI approval. It is simple. So before that, so this video lecture overview, I will be giving the overview of this lecture. So what are the things I am going to cover? So first thing, market analysis. You should analyze the market about the what are the electric motorcycle available in the market, including price. You should analyze. Second thing, what is the customer requirement? What is the customer requirement in e-bike? What they are expecting, whether the petrol bike can contribute the same facilities in the electric bike, like that they will be thinking about the customer requirement. We should analyze that also. So basic assumption and constraint. So we have to decide what is the maximum top speed of the vehicle, like that. What is the maximum loading capacity? What will be the mileage of the bike? Like that we have to assume first. Later, this lecture cover motor power calculation, then motor speed torque calculation, then sixth thing, selection of motor. So selection of motor, what type of motor I should select. Next, selection of battery, lead acid or lithium ion battery, depending upon the application. Then battery capacity calculation. We should know the battery capacity calculation. So for depending upon the mileage range, what the customer needs at low cost, like that we can analyze. Later, battery design with BMS. We are going to discuss this in detail later. Charging time and current required for the battery. So these are the 10 things, important things you should do before produce a prototype. Before producing the prototype, you should do this 10 things. We are going to discuss this in detail. I'm going to discuss this in detail. So first thing, I'm going to analyze the market analysis. So this is a very good business that e-bike is very much increased globally, and it is expected to reach $13,864 million by 2025 worldwide. This is increased. The profit is much more increased. The global sale of electric scooter and motorcycle is increased. So why? Because tax concession for e-vehicles. So environment condition. So to avoid the pollution and to save our mother earth, so we should go for the electric mobility. Also low maintenance cost for electric vehicle. So these are the three things important why the electric bike business is growing globally. Tax concession, also we can get subsidy for getting the electric vehicle. So environmental condition to save our mother earth, for pollution free earth. Also the low maintenance cost of the electric vehicle, because the engine will be not there. So the only thing, the cost of the battery of the electric bike decides the cost of the overall vehicle. So that will be the one disadvantage. Otherwise everything in the aspect of maintenance and environment friendly, pollution free, getting subsidy or tax concession, the electric bike is very much good choice, good business opportunity. So there are many companies worldwide. So in worldwide, the top 5 companies are in China. They are making electric motorcycle and scooter. They are the top 5 companies in the world. So other companies are there: Ampere Vehicles Private Limited, V-Moto Limited, Hero Electric, Revolt Motors, Energica Motor Company, BMW, Mahindra. So there were many startup companies in India also. So you have to analyze all the electric scooters and electric motorcycle of these companies. So what is the variety they has, and what are the disadvantages, so that also you can rectify in your own product. So or at low cost also you can produce than these competitors. So these are the market analysis you should do. So customer requirements, second one, customer requirements. So what the customer need, you have to refer that one also. So what the customer and youngsters want means the torque and speed that should be equivalent. The torque and speed of e-bike is equivalent to IC engine motorcycle. Also they need some noise also. In one Indian bike they have that artificial noise also. So this the thing the youngsters want. Next, load carrying capacity. So for passenger or some commercial vehicle, what is the load carrying capacity, whether it can bear some load 100 to 150 kg, like that it can withstand the load that electric bike is bear up, like that they want to know about the electric vehicle. Also they need gradability, important thing. Gradability, it is nothing but the vehicle will be going in a straight road, also in taper hills the vehicle should go. That gradability should be very good in e-bike. That is also the customer requirement. Also they need long lasting battery, that is long range, because in many countries or in India you can take the charging station is not yet built up overall. So when the charge is out, then where they can charge, at the midway or in the mid of the highway, like that. So the battery should be long lasting. This is the important thing the customer needs. Also they want fast charging. So these are the things we should take care while designing an electric bike, because in the petrol vehicles you can refill the petrol in some set of minutes, you can refill, but charging the electric bike is a difficult thing. It will take some 3 to 4 hours charging. So that they will be offering, they will be need, the company should offer long lasting battery for that customer. So fast charging, it is also the thing they need. Also charging station availability, whether it is there, so that we can buy the electric motorcycle, like that they will be thing. Also available of spare parts, because once any damage or repair will happen, the motor and battery should be replaced with the some spare parts. The available of spare parts store, easily available shops should be there, or the company should provide. Also the service stations of this particular company, authorized service station of that particular electric motorbike company should be there to repair their vehicle without any difficulty. Because in long distance only they will be going to repair that their electric bike, means that will be waste of time, or it will time consuming process. So service stations should be available. Also the bike should be of reasonable cost. So government subsidy, the government subsidy, whether any tax concession for electric bike is there, the people, the customers are seeing these kind. So these are the customer requirements we should keep in mind before starting our own company. So in the overview I have said many things. So market analysis and customer requirements we have finished. The third step we should do is basic assumption and constraint. So I'm going to design an electric motorcycle. So what are the basic things I need to constrain first? So some of the things I have this is the trial and error. If the top speed or other things are not I cannot do for that affordable price, means we can change. So we should do these four things as a constraint, basic assumptions. Four things: purpose, for what purpose we are making this motorcycle, whether for passenger or some sports or some commercial things, or for what purpose we are going to design this electric motorcycle. You have to first assume this is must. Second, what is the curb weight, what is the overall weight of the electric bike, what is the overall weight of the electric bike. Next, the top speed of this electric bike. With the acceleration also we can decide first. Next thing, load carrying capacity. So what will be the maximum load carrying capacity of this electric motorcycle? So we have to assume this first. Also I missed one. So range, what is the maximum range, that is mileage of this electric bike per single charge? So these are the assumptions we should keep in mind, that is purpose of electric motorcycle, for what purpose I am going to design. So what is the total weight of the without the passenger and loading, what is the total weight of the electric motorcycle, what is the top speed we want to achieve in our motorcycle, and also the acceleration. So what is the maximum load carrying capacity of this electric motorcycle, what will be the maximum mileage per single charge, for a single charge how much kilometers or miles it will be go. So these are the things, important thing you should note. Next, so for example, in this video I am going to completely design an electric motorcycle. You can change the datas whatever and wherever you want for making your own motorcycle and get the ARAI approval and start your own business. This is a simple thing. So now I am going to design an electric motorcycle. What are the assumptions? So what are the things I have made? So for a purpose, for not commercial, for passenger thing I am going to design with 2 persons. So Second thing, curb weight. I'm going to design this bike for overall weight of 120 kilogram with everything, motor, battery, everything. The bike curb weight is 120 kilogram. Next, the top speed I want, because after the customer review, customer requirements only we are going to design. So if the cost is not affordable for the customer, you can change the curb weight, the maximum speed, the mileage, you can change. So I have taken this as an example. Top speed 100 kilometer per hour I have taken as an assumption, top speed. Then acceleration I got take for reaching 0 to 100 kilometer per hour, it takes 10 seconds, or according to your wish or whatever the possible thing you can change, you can reduce this seconds. I have taken 10 seconds. Also the loading capacity, I have taken as 150 kilogram, that is 120 kilogram bike weight, and loading capacity, maximum loading capacity 150 kilogram. So the total, for total 270 kilogram I am going to design this electric motorcycle. Later range or mileage, so according to the battery cost and the motor power, you can design this. So later I will be discussing. So according to your wish you can choose. So according to the customer requirements you can change this. If you want to change the curb weight of the bike below this value also, you can change. You can, if you want to change the loading capacity, you can change. If you want to change the top speed, no, I want just 160 or 50 kilometer per hour is enough for me, means that also you can choose. So these are the example I have taken. So these are the constraints you should make before design. You are going to design your electric motorcycle. So far we have seen the three things in the overview I have said. So for getting the ARAI approval, these calculations should be done. So these engineering calculations like motor power, torque, RPM, motor, that is motor speed, or then battery capacity, overall range, that is mileage of the vehicle, then loading capacity, top speed. So all these parameters with the engineering calculation will be asked for verification, and that will be tested by the ARAI to get certification, so that you can start your manufacturing. Also you will be getting some subsidy from the government for your electric motorcycle. So there are many some steps are there for getting ARAI approval, that is how to apply, who will be verifying, how much cost it will be taking, like that the discussion will be discussed later. So far we have seen So this one we have seen market analysis, customer requirement. So this is the important thing in R&D, research and development, so that they can satisfy the customer also, and they can also profit the company also. So what are the ways to satisfy the customer also, and that will be profitable to the company also? This is very important. And also we have seen the basic assumption and constraint. This is also the important step. So before we are going to design, we should keep in mind that we should do the basic assumption and constraint, that is the top speed, what is the mileage of the bike, loading capacity, how much persons it can accommodate, like that. So we should do that also. So in this 3 steps, the 4th step we should do is motor power calculation. For these assumption and constraint, what is the motor power of the electric bike we require? I am going to calculate this one. Fourth one, motor power calculation. So in terms of horsepower or in terms of kilowatts, we should certainly we should tell to the ARAI. So how to find out with these constraints, how to find out the motor power? So what we have taken, the first constraint we have taken, what is the taken? I'm going to design an electric motorcycle with curb weight. We have assumed 120 kilogram, loading capacity 150 kilogram. So totally you will be getting 270 kilogram. For this 270 maximum loading only, we have to design the motor power. For maximum loading only, we should design with the top speed of 100 kilometer per hour, because I told no, the customer, to satisfy the youngsters, it should be at least 100 kilometer per hour maximum speed. If you want the motor power, the motor cost and battery cost is somewhat expensive, if you feel, means you can surely choose the less speed and less mileage, so that you can give at an affordable rate to the customer. So in this example I have taken this. You can change the values in your own design or calculation. So total, I'm going to design electric motorcycle with curb weight of 270 kilogram with the top speed of 100 kilometer per hour. So whenever a vehicle travels in a flat surface also, or that surface condition may vary, smooth or rough surface, or maybe some gradient it should go, so that there is some gradient angle also. So in all the conditions the vehicle should, our electric motorcycle should go. So considering all these conditions, flat surface, whether the surface may be smooth or rough, or the gradient surface, hills, so for all the conditions we should design. So this means every vehicle, any automobile should overcome these three resistance forces. Any automobile should overcome these three resistance forces, so that it will be propelled forward, namely rolling resistance, gradient resistance, and aerodynamic resistance. It means air drag. So these are the resistance forces offered to any automobile. So this automobile should overcome these three resistance forces to get propelled forward. So for the automobile to get propulsion, it should overcome these three resistance forces. That is, what will be the total resistance force? The total resistance force F total equal to force due to rolling resistance plus force due to gradient resistance plus force due to air drag. So we should find out this total resistance force, that is the sum of rolling resistance, gradient resistance, and aerodynamic resistance. This total force, if we find out, means which power of motor will be helpful to overcome this total resistance forces. So that motor power will be helpful to propel the vehicle in forward direction. So one by one we are going to find out. So on the overall, if you want to see, means what is the rolling resistance, gradient resistance, in a single picture we can show. This is the flat surface, or this is the some gradient surface, some bridge, maybe a hill, like that, whatever the condition. So our vehicle should move, our motorcycle should move, means, so what is the thing we need? So rolling resistance, so this is the resistance offered against the direction of motion of vehicle. This is the direction of motion. This is the direction of motion, means the rolling resistance is the force offered against the direction of motion. I will explain it later. Then the aerodynamic force is nothing but the air resistant forces. When we are driving our vehicle, this is the wind resistance, so it will oppose our motion, so it will be opposite. So we can say uh, the speed of the wind and the direction, the speed of the vehicle, we have a relation that I will be telling in formula. So also this will be the uphill gradient, so this is also an opposite force. This is the direction of the vehicle, so the gravity will make the vehicle to move downwards, because this will be the center of gravity point. Example I have taken, center of gravity point, the vehicle total weight will be acting. So in the gradient uphill, so this gravity will try to pull the vehicle in downward direction, so that vehicle should overcome this gradient resistance, so that it can go in the hill area. This is the overall forces we have to find. Number 1, rolling resistance. So what is rolling resistance? So we'll be taking some photos. So this is the one wheel I have shown. So this wheel, what will be the direction of motion of the vehicle in this direction, and total weight will be acting as a force also here. So the direction of rotation in this direction, so will be the vehicle will be moving forward. So this is the rolling resistance force, that is rolling resistance means friction between wheel and road surface. So there will be some friction between the wheel and the road surface when the vehicle is moving. That wheel is rotating on a road surface, a frictional force will be oppose the rotation. Also the road surface may vary, it may be asphalt road or a normal I will be telling in tabulation, smooth road friction will be less, so rough road surface, in a sand road, so everything the wheel should meet is going to meet all the road surface condition. So for that we have to design. So it has a formula, F rolling resistance, it has a formula CR into M into A. So CR is nothing but coefficient of rolling resistance, it is a constant value for different road surfaces. In tabulation I will be showing. So m is the mass of vehicle in kilogram, so a is nothing but acceleration due to gravity, in meter per second square, 9.81 meter per second square. So if we'll be substituting all these values, we'll be getting the F rolling, that is the resistance force we want to overcome. So mass of the vehicle, we know, we have taken 270 kilogram. You may take the weight of the vehicle 120 kilogram. So one person may sit, two persons may sit. So what is the maximum loading capacity of the motorbike? So for that I am designing. So the resistance force will be very much more. If you choose 120 kilogram, the weight of the bike alone means that will be different. So I have taken the maximum load, maximum mass of the vehicle. So A is nothing but 9.81 meter per second square. Okay, then we should take the coefficient of rolling resistance value from one tabulation, from this one, rolling resistance. So if you see this tabulation, you can find these are the practically obtained values for different road surfaces. If you see these values, railroad steel wheels on steel rails 0.0012 to 0.002. So what we want, if you want to choose an electric bicycle, you could take bicycle tire on wooden track. Wooden track means wooden road condition. For that the value is 0.001. Next, the low resistance tubeless tires 0.002 to 0.005. So note these three, this is important for us, these three values, that is bicycle tire on concrete road 0.002, bicycle tire on asphalt road 0.004. So these are the things we are going to see. Also some of the other parameters are there. If you want to design an truck, electric operated truck, you can choose this. So again, bicycle tire on rough paved road, also it is given 0.008. So if you want to design an electric car, you can take this value, ordinary car tires on concrete new asphalt cobbles small new. So car tires on tar or asphalt 0.02. For using the electric car design, you can make use of this table. So on the whole entire table, the different values has been given. Car tires on cobbles, car tire on solid sand, gravel, loose one, car tire on loose sand, so that slip will be more, so that the value is highest in this table. If you see the whole table, the value is highest for car tire on loose sand. In our practical experience, if we will be driving the car, we will be experience. So the rolling resistance coefficient is 0.2 to 0.4 maximum value. So now for our bike, what I am going to choose, that is important. What I am going to choose is this one. Bicycle tire on asphalt road is there. Bicycle tire on concrete is there. Low resistance tubeless tire is there. So I'm planning to have tubeless tires for our electric motor bike. So in that it is given 0.002 to 0.005. So I'll be taking 0.004 as an average. That is also suitable for bicycle tire on asphalt road. That will be suitable for bicycle tire on concrete road. So for concrete road, asphalt road, tubeless, low resistance tubeless tire, so everything I have taken as an average of 0.004. So this is important to select, because whatever if you select a wrong value, the answer will be different. So that I will be taking. So after that we can go and substitute here. So what I have taken, CRS 0.004, 0.004 into 270 kilogram into acceleration is 9.81. So after calculating, we will be getting the answer as 10.59 Newton. F rolling 10.59. So first resistance forces we have found. So next resistance forces, gradient resistance, so gradient resistance is nothing but when a vehicle is running on a slope or hill. So this also you should consider. When it will be going on a slope surface, the rolling three forces will be acting only. So take this as an center of gravity. This is the weight of the total weight of the vehicle will be acting, that is mg. We can say this is as weight. The rolling resistance offered is F rolling. So also there will be air resistance, wind resistance will be acting. So gradient resistance, I want to highlight, this is the gradient resistance. So without any drive force, this is the drive force the motor will be giving, drive force. Without this force, the gradient, what will the vehicle, what will happen to that vehicle? It will slips downwards. It cannot go upwards to the hills. So this is the gradient resistance. So this also a matter to be considered. So F gradient m into a into sin theta. So m is the again mass of vehicle in kilogram. A is the acceleration due to gravity. This is important in gradient distance, acceleration due to gravity in meter per second square. Theta is the gradient angle or slope angle or hill angle. So it may be a bridge. So m is the mass. What is the mass? 270 kilogram. Acceleration is 9.81. Theta is the angle. It varies 0 degree for flat surface. Theta will be 15 degree to 22 degree for slope surface. So the power will be more, that peak power. So in trial and error method also we can test, we can do a prototype and have a motor arrangement in that, and we can test which type of hill it is able to overcome this gradient resistance force to go upwards. The vehicle we can test. So now I have taken F gradient for flat surface. So after substituting we will be getting 0 Newton only. So next, final one, aerodynamic drag. So aerodynamic drag is nothing but the wind resistance force. Aerodynamic drag is nothing but wind resistance force offered opposite to the motion of the vehicle. It has a formula. F aero drag is equal to 0.5 into rho, that is density V square into Ca into AF. So rho is nothing but the density of air medium, because this is the air offers resistance forces to the vehicle in kilogram per meter cube. V is the velocity of vehicle in meter per second. So we have taken some 100 kilometer per hour. No, so we have to convert it into meter per second. Ca is nothing but the coefficient of air resistance. Next, final one, AF is nothing but frontal area of bike. What is the front? If it is a car, the frontal area of the car, like that, in meter square. So what are the things we want to take as? So I have taken rho equal to 1.23 kilogram per meter cube. That is, if you search, you can Google it. Air, what is the density of air at sea level? What is the density of air at sea level? I have taken 1.23 kilogram per meter cube. So V is the velocity of the vehicle. What is the top speed? 100 kilometer per hour. So you can convert 100 into kilometer. So you have to convert it into meter per second. Multiply with 1000 divided by 3600. You will be getting 27.77 meter per second. That is 1 kilometer is equal to 1000 meter. So hour we have converted into second, 60 into 60. That's what we have got, 27.77. So CA value, coefficient of air resistance for bike racing, I have taken. So it is also can be tabulated. This is the different air coefficient. It find out practically, laminar flat plate, dolphin. If you see this one, aeroplane wing, modern car like Tesla, the famous electric car, Model 3 and Y model has 0.23. They have found practically. Tesla model, Toyota sports car, like that. So for bird also aerodynamic resistance is there, 0.4. So I have taken the bike racing. See this bike racing. If you want to design for a car, you can take some value. So bike racing is 0.88. So 0.88 for bike racing I have taken. So remaining only one thing, we have to find AF, frontal area of e-bike. So this also has a set of steps you have to do. After that only you have to find the frontal area of the bike. So we can substitute in aerodynamic formula. You will be getting the aerodynamic force, that is aerodynamic resistance force. So next step is we have to find out the frontal area of the vehicle. So how to calculate the frontal area of the vehicle? How to calculate frontal area of vehicle? So whatever the electric car or electric scooter, electric bike, you can follow these same steps. 3 steps are there. Number 1, you have to draw this chase design, bike chase is design in any 3D software. So according to your wish, what will be the wheelbase, what will be the wheel track, the handbar length, overall height, ground clearance, everything you can refer some other bikes also. You can refer and draw in 3D form. So after that, convert that 3D to 2D. So you'll be getting, after converting into 2D, you'll be getting different views: front view, top view, side view. So in that, we want to select the front view. Why I'm selecting this front view means, this front portion of the bike is affected by the wind resistance force, so that I am taking this front view. I'm taking the front view. So how to, after converting it into 2D, how it look like? If you see the picture, see, so the 3D picture we have drawn with the passenger. That is important. You should not draw the bike chase alone. You should draw with the passenger with the helmet, because these are the maximum conditions we are designing. So with the passenger 3D, have some person, imagine have person in the bike wearing helmet, and this will be the 3D. So convert that 3D into 2D. So in that 2D, take front view alone. So I have taken this front view alone. So measure the height and width of the bike. I mean, so the width will be the length between the two handbar. Measure this one with 780 mm, and measure the height of the bike. It means from the ground to the passenger's helmet, up to that you have to select, not up to the height of the bike, up to, because these are the things the air resistance forces will affect. So this will be some 1630 mm. So take some any bike reference, try some prototype, okay, so that you will be getting this values. So I have got this height and weight. Then later what I should do is multiply that height and weight, that is frontal area is nothing but height into weight, height into width into adjusting value. So adjusting value is nothing but, in simple tabulation I will be telling, for cars, bikes, trucks and buses. For cars 85%, bikes 70%, 100%. These are the adjusting values. Adjusting values. Why? Because for trucks and buses, you see 100% means the buses and trucks will be in 100% some rectangular shape. 100% buses and trucks will be somewhat, so that you should 100% is nothing but one factor. So we cannot choose the adjusting value. So for bikes it is curved surface, see, curved surface, something it is irregular, so that I am taking the adjusting value as 70 percentage. So what will be getting, so height is 1130 mm. So for getting area in meter square, I should substitute in meter. 1.63 meter into 0.78 meter, that is 780 mm, into adjusting value is 70% for bikes, I told 0.70. So if after calculating I will be getting 0.89 meter square. 0.89 meter square. So we should go and substitute in aerodynamic in this formula. We can substitute. So here we can substitute 0.5 into rho, I have taken 1.23 into velocity, it is the square of the velocity will be the velocity of the vehicle is the square directly proportional to the aerodynamic drag. So velocity is in meter per second 27.77 square into CA we have taken for bike racing 0.88 into AF we have calculated 0.89. Okay, so after substituting and calculating we will be getting 371.45 Newton. So we have find out the three resistance forces. That is total resistance force F total equal to F rolling plus F gradient plus F aerodynamic drag. So substitute all these values. F rolling 10.59, gradient for flat surface and aerodynamic 371. So on the total we will be getting 382.04 Newton. So the motor cycle has to overcome 382 Newton resistance force to get propelled. So this is the important step we have found. The total resistance force we have found. So to overcome this force, that is 382 Newton, we can find the power required, that is propelling power required to overcome this resistance force. So we know that power equal to total resistance force into velocity of vehicle in meter per second. So you may think how we have got this formula like that. The total every action has equal and opposite reaction. So this is the total force, means we have to offer that same force or greater than that force to propel the vehicle in forward direction. So that will be the velocity of the vehicle will be helpful to overcome that force. That is in the unit also you can check. So power unit is watts. In SI unit it is Newton meter per second or joule per second. 3 units power: watts, Newton meter per second or joule per second. Here the force is there. Force is nothing but mass into acceleration, that is kilogram meter per second square. So here velocity of vehicle is there, meter per second, in terms of meter per second. So totally for getting that power, this is the formula: total resistance force into velocity of vehicle. Simply we can say the resistance force is in Newton, velocity of vehicle in meter per second. So Newton meter per second is nothing but joule per second, which means watts. Simply this one you can remember. When compared to previous explanation, this explanation is quite good. So we can substitute power is equal to the total resistance force 382 into multiplied with velocity of vehicle is 100 km per hour. In meter per second 27.77 meter per second. So if we calculate, you will be getting 10,608.14 watts. Watts is nothing but Newton meter per second. So we can take as 10.6 kilowatt. This is the maximum power required for our vehicle. So we have concluded that to run an electric motorcycle with a gross weight of with a gross weight of 270 kilogram and a top speed of 100 kilometer per hour. We need 10.6 kilowatt motor. So you can take this as a peak power of the motor. So there are two terms in motor: continuous or rated power, peak power. So in the motor specification, commercially available specification, these two terms are used. So we have a relation the rated power is some 2 to 5 times the peak power. So in from this relation I want to conclude so I'm going to take 5 kilowatt rated power, 10 kilowatt peak power motor for this electric bike. So this is my conclusion. I'm going to commercially buy the 5 kilowatt motor for this electric bike with the peak power of 10 kilowatt hour. Also, if you change the loading capacity, that is, we have taken the loading capacity as a 150 kilogram, the bike weight is 120 kilogram, we have taken. So depending upon the loading capacity it may vary. So please compare with the commercially available electric motorcycle. So what are the motors they have chosen in commercially available electric motorcycle with the top speed of 100 kilometer per hour, loading, everything you can check. So what is the motor they have used? If you see, means somewhere between they will be using 3 kilowatt to 10 kilowatt. In this range they have chose some motorcycle 4 kilowatt, 5 kilowatt, 6 kilowatt, so 10 kilowatt they have choose. So no problem, for my bike I have chose 5 kilowatt motor. This is my conclusion. So we have seen the overview, we have seen the market analysis, important customer requirement, basic assumption, and motor power calculation. We have chosen as 5 kilowatt continuous power or rated power and 10 kilowatt peak power we have chosen. So next you should find out the motor torque, motor speed, initial torque required to move the vehicle, later we can tabulate the complete motor specification. We can tabulate the complete motor specification so that we can buy it commercially. So for that motor, what battery will give you certain mileage or range for your electric motorcycle, that also we can decide later. So these are the things I have chosen. So we have found out the peak power and rated power of motor required to overcome those resistance forces. So now we are going to see in the overview also. We have found the motor power calculation. Now we should see the motor. We should find out the motor speed in RPM, torque calculation and all. So how to calculate the motor RPM, that is speed, motor torque, and maximum torque required initially to move the electric motorcycle. So these are the things we are going to discuss now. So first see the wheel, the motorcycle wheel. I am going to find out the wheel RPM first. Wheel RPM. So for that draw this wheel. This is the wheel. So this is the center of the wheel and this is the radius, and overall this is the diameter of wheel or motorcycle wheel. So the diameter of motorcycle wheel D is equal to, I have taken 432 mm. It means for your motorcycle you can select the commercially available things, or for the required torque you can manufacture your own motorcycle wheel. So for reference, first for producing the prototype you should buy the commercially available motorcycle wheel. This is not like scooter and all, it is a motorcycle. So I have taken the standard size for analyze the electric motorcycle in the market. So what is the common? So I have taken that 432 mm, that is 0.432 meter, and correspondingly the radius should be, the radius of wheel should be half, 0.216 meter, right? So diameter, radius, so I have chosen some wheel for our bike, right? See, this is the motorcycle wheel. This is the motorcycle wheel. Here I have drawn. Okay. See, this is the circumference. See, from the ground I have taken, this is the circumference of the wheel, 2 pi r. This is radius, as I already said, radius 0.216 meter, 0.216 meter radius. So for one revolution, this one, if the wheel runs at once, one revolution, for one revolution of wheel, it is rotating like this and rotating like this. So the wheel, for completing one revolution, it will be taking 2 pi r distance to cover in the flat surface. It means for one revolution of wheel, it covers 2 pi r distance in the road, right? For one revolution of wheel, it means one revolution of wheel equal to 2 pi into 0.216 meter. The answer will be 1.357 meter. This is the distance covered for one revolution of wheel, right? So what we have taken, the top speed of motorcycle, electric motorcycle, we have taken as 100 km per hour. If the bike is riding at a maximum speed of 100 km per hour, so I am converting this 100 km per hour into meter per minute. It means 100 into 1000 divided by 60. I am not converting into second, into minute. 1666.66 meter per minute. It means when a bicycle is riding at a top speed of 100 km per hour, it means when a motorcycle drives at a speed of 100 km per hour, it will be reached 1166.66 meters in 1 minute. In 1 minute, the bike will be reached 1666 meter. Right? So, what is the maximum wheel RPM? Maximum wheel RPM is equal to ratio between distance reached per minute at top speed and distance covered by wheel in 1 minute. Thousand 1666.66 divided by 1.357. So the maximum wheel RPM is equal to 1228.19 RPM at top speed. At 100 km per hour top speed, the wheel RPM, motorcycle wheel RPM will be 1228.19 RPM. So I am going to find the motor RPM. So this is the wheel RPM. So what will be the motor RPM? Motor RPM. So how to find motor RPM? So I have taken, this is not a hub motor. Hub motor I will explain in detail. The hub, the rotor and the stator arrangement will be there in the motor. The rotor will be at the center of the hub of the wheel itself. But the gradability and torque are poor in that. For motorcycle consideration, I have taken the mid motor chain drive with the chain drive and sprocket arrangement. I will show the figure. The motor RPM will be equal to sprocket ratio into wheel RPM. We have found already at the top speed. So this arrangement we have taken, consider this is the wheel, our motorcycle wheel, and this is the motor. This is the motor and this is our wheel. So this is the mid motor. Mid motor is nothing but the motor placed between the wheels and the footrest of the driver. So this will give good gradability, that is when compared to hub motor, it will go to up hills easily. The bike will overcome the gradient distance easily. So for that I have chose this. This one, driver sprocket, motor driven sprocket. This is the wheel sprocket. So we know the wheel RPM. So from wheel RPM we can easily find the motor RPM by this sprocket ratio. So this figure will clearly explain you. Okay, we can take this figure, both are same only. See this is our wheel RPM. This is the motor. So this is the wheel sprocket. So from this we can find the motor RPM. So motor RPM equal to sprocket ratio. So what is the sprocket ratio? Generally we will be taking 44/12 into wheel RPM 1228.19. So this sprocket ratio means why I have taken 44/12. So driven by drive, that is this 44 teeth is for the wheel sprocket and 12 teeth is for the motor sprocket. Sprocket ratio, take this formula, number of teeth in wheel sprocket divided by number of teeth in motor sprocket. Okay, so 44 teeth, 12 teeth. This also you can take this as a reference from anything, and we have to design a prototype and manufacture it and test it. If it is not good, we can change the sprocket size to get more torque, or like that, trial and error we can do this. So motor RPM will be 3.66 into 1228.19. So that motor will be getting 4495.17 RPM. Motor RPM we have calculated. So what will be the torque of the motor? Next, motor torque. So we know that already. Power, we have a formula 2 pi nt by 60. This is the motor power and this is the motor rpm, and T is the torque of the motor. So I have taken 5000, that is 5 kilowatt motor. The motor power is 2 pi. N is the motor rpm. We have found previously motor rpm is 4495.17. So we have to calculate the torque, motor torque divided by 60. The torque will be 10.62 Newton meter. This is the motor torque. There are two types of torque also there. This one is rated torque and this one is rated torque. So what will be the peak torque? Peak torque will be 21.24 Newton meter. Okay. So what are the things we need for the motor? We have found exactly. We have to compare it with the commercial available. We cannot manufacture the motor in our company. What we have said, we can ask for the client to supply a good motor according to our specification. So we have found out the motor specification. I'm going to tabulate it. So first one, we need voltage. Then what is the rated power of motor and peak power of motor? What is the speed of motor? What is the rated torque of motor? What is the peak torque of motor? What is the efficiency of transmission? So dimensions, what is the size of the motor? What is the weight of the motor? And what is the cooling type used for that motor? Okay. So voltage available or 48 volt, 60 volt or 72 volt or 96 volt are available commercially. For getting this type of top speed 100 kilometer per hour and this rated power 5000 watts, that is we have chosen 5 kilowatt motor. So for that this 72 volt is better. 72 volt we can choose instead of 48 volt or 60 volt. 72 volt is good for top speed 100 kilometer per hour. So accordingly the same 72 volt battery we should select. So what is the rated power we have chosen? 5 kilowatt. So what is the peak power? 10 kilowatt. So rated power also means continuous power. Speed, what is the motor speed we have calculated? 4495. This is the motor speed for achieving top speed. This is the motor speed achieved for top speed. So there will be also minimum speed also, some average 50 km per hour, some 40 km per hour. So speed what I am going to select is commercially available 3000 to 5000 rpm. 3000 to 5000 rpm. So what is the rated torque and peak torque we have calculated? So rated torque is 10.62 and peak torque is 21.24 Newton meter. So rated torque 10.62 Newton meter and peak torque is 21.24 Newton meter. So the efficiency efficiency is also important. 85 to 90% I have taken for this one. So you can compare with the commercially available motor. It will be more or less equal to same what we have found. The dimensions also you can check the manufacturer, what they have said. This one is compact size and this one is big size. So according to the bike chase, you can select the motor size dimensions. Some company will be giving also the weight, also the manufacturer. So according to our requirement we can choose. And cooling is also more important. So both are available, air cooling and or liquid cooling, because the motor will be heated up. So accordingly we can select. So this 5 kilowatt motor with the peak power of 10 kilowatt motor, we may choose the air cooling. So for some other motors, some high rated power motor, they will be choosing the liquid cooling for cooling. So in this air cooling, one cooling fan will be provided for cooling that electric motor. So these are the various specification we have found out successfully, the motor specification. This is the important primary step to calculate for the electric motor cycle. So this motor is very much important because this motor is providing the torque, required torque and required speed, everything. So for this motor we can select the battery backup according to our budget of the bike. It should be profitable and also affordable to the customer also. So this is the first primary step we have completed, and we have some doubt, like what we have doubt, what motor to choose. That also I will be explaining. Motor specification we have got. So what type of motor? Brushless DC motor, AC motor, induction AC motor, or brushed DC motor, like that, hub motor or mid motor, like that we'll be discussing. So before that, this calculation is also important to find out, that is maximum torque required to move the motorcycle initially. In normal IC engine bikes, you might have noticed IC engine bikes have gearbox, 4 speed or 3 speed, 5 speed, 6 speed, etc. So we'll be starting the bike initially at first gear only, because first gear will provide more torque than any other gear. First gear, so that we are starting the bike with first gear. So in this electric motorcycle, so we need to find the initial torque required to move the motorcycle, so that we can set up accordingly in the motor to give the initial torque, which will be equivalent to the first gear in the IC engine bikes. So this is important calculation. So how to find? We know that Newton's law of motion. Newton's law of motion, one of the law, V is equal to U plus AT. This is the important universal formula, you know. V is nothing but the final velocity in meter per second. U is the initial velocity in meter per second. A is the acceleration in meter per second square, that is motorcycle's acceleration. So T is the time taken to reach maximum speed from rest in seconds. Okay. So I have taken velocity, maximum velocity is 100 km per hour. In meter per second it is 27.77 meter per second. I already told. U is the initial velocity. The bike will be at rest, it is 0. And T I have taken as 10 seconds. That is, when you start your vehicle, to reach from initial velocity 0 to maximum velocity 100 km per hour, it will take 10 seconds. For fastest bike, if you want some 8 seconds or 6 seconds, 4 seconds also, if you can take that also. I have taken 10 seconds, so accordingly you can change if you want. V is equal to U plus AT. So V is nothing but 27.77 in meter second velocity. Initial velocity 0 plus acceleration I have taken. The time taken. I have taken 10 seconds. We need to find the acceleration A. The time is 10 seconds. So the acceleration of the motorcycle is 2.77 meter per second square. I have found. So why I have found this acceleration means, so this picture will clearly shows you so here what we are finding, torque we need to apply at initially to start the vehicle, like first gear in our gear bike. So this is the initial torque required. I am going to find this torque, this twisting moment is, this initial torque is nothing but what we want, that force into distance. Force into distance. This torque will be equal to force into distance. The distance is nothing but from the center of the wheel, that is radius. This is the radius of the bike. So the initial torque we require is torque equal to force into radius of wheel. So we know that force is equal to mass into acceleration. So radius of the wheel we already know something. So for substituting this acceleration only, we have found out here acceleration we have found. So I am going to substitute here. So torque equal to force into radius of wheel. Force is equal to mass into acceleration into radius of wheel we have taken as 0.216 meter. 0.216 meter. Mass of the vehicle is 270 kilogram. Substitute mass in kilogram only. Mass in kilogram only you have to substitute. Acceleration we have found 2.77 meter per second square into 0.216 meter. So the torque is 161.54 Newton meter. Say for ease calculation 160 Newton meter I have taken. It means 160 Newton meter initial torque is required to move the electric motor cycle from its rest. This one is very important. Like in first gear IC engine motorcycle, for electric motorcycle we should find this also. So we have seen the initial torque required to move the vehicle initially. So now we are going to see about the selection of motor. This is also an important selection of motor. There are many types of motor used in electric vehicles. So we are going to discuss now. Also from the types I am going to select any one type for our electric motorcycle. So this selection of motor. So this motor is the core element. This is the important element apart from electric vehicle batteries, because it replaces the IC engine. So for providing the torque equivalent to IC engine, this electric motor plays an important role in an electric vehicle. So the rapid development in the field of power electronics and control techniques has created a space for various types of electric motors to be used in electric vehicles. So electric motors used for automobile application for this electric vehicle should have high torque, high power density and good efficiency. So these are the requirements of good electric motor, so that it will be equivalent to the ICE engine for an electric vehicle. So now we see the various types of electric motors. Types of electric motors used for EVs. So there are certain types. Number 1, DC series motor. Number 2, brushless DC motor. And third one is PMSM. This is also an important motor in electric vehicle. One electric bike has PMSM motor. I think it is a Harley Davidson or a something M Flex one. I don't remember. So it means permanent magnet. So it is a costly motor because it has a permanent magnet. Synchronous motor. Next, fourth one is 3-phase AC induction motor. So this is also a famous motor in electric cars used by Tesla company. And fifth one is switched reluctance motor, simply SRM. These are the 5 types of motor used in electric vehicles: DC series motor, brushless DC motor, PMSM, 3-phase AC induction motor, and SRM. So one by one we are going to discuss why we should study these motors in detail, means so that we can conclude this motor will be suitable for my electric vehicle, like that. So without knowing the basics we cannot select as if others are selecting. So first one, DC series motor. So this motor has a high torque capability. So this is used for some traction application. So it was the widely used motor for traction application in early 1900s. This is the motor used in early 1900s for traction application. So the advantages of this motor are easy speed control. So also it can withstand sudden load it can withstand. So all these characteristics, that is easy speed control, withstand sudden load. So it is these characteristics make it an ideal traction motor for these applications. But there are some drawbacks also. So the drawback of these are the advantages. So it also has disadvantages, that so high maintenance because it has brushes and commutators, brushes, because these are brushed DC motors. It has brushes and commutator. So for maintaining those things it is very much difficult. So they are used in Indian railways. So Indian railways using this DC traction motor. So, and we are not using this for electric motorcycle. So next, brushless DC motor. This is a BLDC motor. This is BLDC, brushless DC motor. It has much more advantages than brushed DC motor. So it is famous nowadays for using in electric motorcycles and electric scooters and electric e-rickshaws, e-scooters, e-rickshaws, electric motorcycles, electric bicycles, so etc. They are used. This is nowadays famous. So it is similar to DC motor with permanent magnets, but it is called brushless because it does not have commutator and brush arrangement. It does not have brushes and commutator, so that it is called brushless DC motor. So the maintenance is also reduced, so easy to maintain. The commutation is done electronically in this motor. Because of this, BLDC motors are maintenance free. So also it has good high torque, starting torque, efficiency 95 to 98% it has efficiency. Also high power density it has. So these are the motors nowadays used widely in this type of electric motor, electric motorcycle, electric bike, electric scooters, electric e-rickshaws. But these BLDC motor are again subdivided into two types. One is outrunner type, another one is in-runner type. So in-runner type. So simply I can say outrunner type as a hub motor. This is hub motor, and this one is mid motor. In commercially or easily you can spell hub motor and mid motor. So this hub motor, the difference is there. In this type, rotor of motor is present outside and the stator is present inside. Rotor outside, stator inside. So in mid motor, the rotor is present inside, stator is present outside, like a conventional motor. This mid motor, conventional we are using normal motor, no, that is mid motor. We will be giving chain drive to the wheel. So these are the two different types of brushless DC motor. So there are many advantages and disadvantages in this motor that we will be discussing. So I will show you the figure of both the motors. So this is the hub motor, and if you see the difference you can easily find. This one is hub motor and this one is mid motor. So I already said in the hub motor the rotor will be present at the outside so that it will give initial torque to move the vehicle. It is very compact, this is very compact. Every arrangement will be coming here. This one is the mid motor, will be giving the chain drive or belt drive for the rear wheel through sprocket arrangement. So both are used in electric scooters and electric motorcycles. So we have to select anyone among this. Next we have third one is PMSM. This is also I am going to discuss because this is the important motor used in some Harley Davidson or I think I'll be telling the example PSM, permanent magnet synchronous motor. For sports bike and super bikes and all, they will be using this one. Sports bike, super bikes, we can use these kind of motors. So it is also similar to BLDC motor only, but it is somewhat costly, and because costlier than BLDC motor. This is PMSM is costlier than BLDC motor. So some common examples we can speak. Toyota Prius, Zero motorcycles. I told no, we are designing the motorcycle, so this is also a motor to know, PMSM motor. And Nissan Leaf, these are all the electric cars using this type of motor. So BMW i3, and in Indian manufacturer some I think Mflux, Indian manufacturer Mflux 1. This is India's first super bike using this type of PMSM motor. So the fourth type is 3-phase AC induction motor. So these don't have a high starting torque like a DC motor under fixed voltage and fixed frequency operation, but these characteristics can be altered by using various control techniques like FOC or VF methods. By using these control methods, the maximum torque can be achieved for the electric vehicle tracking application. The efficiency is also good, 92 to 95%, but the drawback of these induction motor is that it requires complex disadvantage is that it requires complex inverter circuit and control of motor is difficult. So these are some disadvantages, but I think the Tesla S model is the best example. I'll show the motor picture. So this is the 3-phase AC induction motor. So Tesla Model S is the best example to prove the high performance capability of induction motors compared to the BLDC motors. Even Mahindra Riva is the India's first electric car produced in 2001. So before the Tesla company was formed, this electric car they have produced in Riva. So later it is converted into Mahindra company. They have used this three-phase induction motor, AC motor, induction motor for electric cars. So also Tata has planned to use these type of induction motor for their electric cars. So fifth one, S or M switched reluctance motor. So the working and all we can see in different occasion. The biggest drawback is the complexity in control and increase in switching circuit. In this motor, the complexity in switching circuit and control also it is difficult. So it can replace the PMSM in future. I think these motors will replace the induction AC three-phase induction motors in future for electric cars. So for our motorcycle, what we are going to design, this is the important thing. For our motorcycle, I'm going to select brushless DC motor. I'm going to select. In that two types I said, hub motor or mid motor. So this is nowadays famous for a electric motorcycle. I have said in that two type we are going to discuss and select which one is good, hub motor or mid motor for our motorcycle. So if you see the difference for both the motors or disadvantages, you can easily find out for our motorcycle what should be selected. So regarding the cost, it is cheaper. One advantage, it is expensive due to the presence of permanent magnets. Also, so hub motor flat and very small hills it can go, but from flat to very steep hills it will go. So easy to replace because it is fitted with the wheel itself. Is somewhat more complex when compared to this one. So it has no chain, no transmission required. Here chain or belt drive required. So from this data we are going to select which one is good. See, I'm highlighting, you will choose. So even the hub motor is cheaper, it is expensive, so hub motor cannot go very steep hills. This is the disadvantage. So the youngsters will be like these steep hills ride. And also, if even though it is easy to replace when compared to the mid motor, the center of gravity is low. Center of gravity is low in this type of scooter. Here the center of gravity is very much good, because the mid motor is placed between the two wheels, so it is the center of gravity is good. So here no transmission is required, but even though the chain, if it is broken, we can change the chain. So for a high steep hills drive, this chain drive or belt drive will be giving more torque for this type of vehicle. So I'm selecting for our motorcycle, we can select mid motor for our vehicle. So if someone wants to design some scooter for about 40-50 kilometer per hour speed, not much gradability it require, they can choose hub motor as well. If you want to start a motorcycle business or a electric scooter business, accordingly you can choose. In short, if I want to climb the hills, we can choose this mid motor. If you want to make more profit, and you can choose the e-scooter business, you can choose hub motor is best. But for the youngsters who do off-road action jumps, some dirt bikes, you can choose this type of mid motor. So for our motorcycle mid motor, I'm going to select. So far we have seen about the selection of motor and motor power calculation. In the overview, if we see means, so we have seen the motor power calculation, motor speed torque calculation, these are very important. So also we have seen the different types of motor, selection of motor. So from that we have selected some BLDC motor. So among them there were two types, hub motor and mid motor. So for considering different many advantages in mid motor, we have selected the mid motor for perfect and good gradability. So when compared to hub motor, even though it is costly, and it will be good for the electric motorcycle, we have seen. So now this is the time to see the selection of battery. This one we are going to see. So what are the different types of batteries used in electric vehicles? So from that we have to select one battery, and also we should select some mileage. According to the mileage, we have to select the battery capacity calculation. So next one is selection of battery. This is very important. Battery is an electrochemical device that can be charged electrically to provide static potential for power. Otherwise, it will release electrical charge whenever needed. So why we are discussing in detail means we should know the basics of all the things, then only we can select a perfect thing and we can justify, for this reason I have selected this one, like that we have to justify. So simply battery will store the electrical energy. So there were a difference between capacitors also. Battery and ultra capacitors, so there is some difference. So it stores electricity in the form of chemical reaction. Ultra capacitors, they store electricity in the form of electric field. So these are the difference. So whether we can use these ultra capacitors in electric motorcycle or not, we can discuss later in some other occasions. Now I am going to discuss about the battery alone here. So there were many batteries used, types of batteries used specially for EVs. I am discussing especially for EVs. Lead acid battery is more common. It is an automotive battery for starting the vehicle. It is very much important. Also many e-rickshaws, e-autos are using this type of lead acid battery, sealed lead acid battery, but more popular in electric motorcycle and electric scooters, and nowadays we are using the lithium ion battery. So second one, nickel metal hydride battery. This is also an there were many differences and some disadvantages. So when compared with all the batteries only, they have chose some, this one is better for this one, like that. Next, lithium ion battery, NMC cell. Simply it is a commercial name, NMC cell. So this is the commonly used nowadays. Lithium iron phosphate is replacing this NMC cell. So lithium iron phosphate is nowadays phosphate is nowadays very popular in electric motorcycle, electric scooter and electric cars, because of high energy density and many more charging time, so many advantages are there. But when compared to the lithium ion battery, lithium ion phosphate is somewhat costlier. It is costlier, but it has many safety features, safety aspects. The lithium ion phosphate battery is improved, but the cost is high. So we can select the lithium ion battery, and also there were other types also, lifelong batteries like lithium ion titanate. So this battery is much more popular. We can use it for electric cars. These are all the lifelong battery. It means they have very long charging and discharging life. Battery life is much more improved. So some up to 10 years to 20 years we can use this lithium ion titanate, but it is more weight, costlier, much costlier, but it has much more advantages. Even though it is costlier, one time investment, lifelong running. So this lithium ion titan is it good for lifelong running. Also the graphene battery is nowadays under research and development. It is going, so up to the mobile phones and all we can use. Regarding electric vehicle, it needs some time to come up commercially. So this is also very good battery. Samsung is doing R&D in graphene battery. So these are some basic types of electric vehicle batteries. So from this we can easily select something. So for our motorcycle, our electric motorcycle, we can choose lithium ion or lithium ion phosphate or lithium ion titanate. Which one I'm going to select means this is costlier than this one cost wise. This cost is costlier than lithium ion battery. Lithium ion titanate is costlier than lithium ion phosphate. and this one is lithium ion phosphate is costlier than this one. So we can select in cost wise lithium ion, it is better, that is NMC cell we can use. So there were much more advantages for this one, but lithium ion is not bad, because for companies profit and all, to reduce overall vehicle cost, we can select lithium ion. So to satisfy the customer, the price should be affordable, so that we are choosing this lithium ion battery. If you want to select lithium ion phosphate, also it is very good. This is very good nowadays. It has more charging cycles, more battery warranty, more safety. It is much more safetier than lithium ion. So now I am selecting the lithium ion. So lithium ion battery we can select. So before that we should understand the basic things, that is battery capacity. Battery capacity, load, runtime. So please know these basic things first. So if a battery capacity is 500 watt hour, okay, the load is 250 watts. The load means any electrical load. Here we can take the motor. So the 500 watt hour battery, when it is running the 250 watts motor, it will run for about 2 hours. That is 500 watt hour is nothing but it will be, this battery will be giving 500 watts power for 1 hour. 1 hour, but this motor is only 250 watts. The motor consumes only 250 watts. So if, the battery can supply 500 watts for 1 hour, then the motor will be running for about 2 hours. So this is the thing you should, this is very important tabulation. You should first understand the basics so that you can answer or justify in the ARAI or to your customers also if they ask. This is the very basic thing. So 500 watt hour battery pack will give, hour means 1 hour, will give 500 watts energy for 1 hour. If a 250 watts motor is running, means it will be running for 2 hours, right? Okay, now you should answer. I am going to change the load, right? The same 500 watt hour battery is there, but the motor is 500 watts. Then how much time it will run? The battery can supply 500 watts for 1 hour. If it is used for this motor, the motor will take 500 watts, then it will run for 1 hour. Okay, now the same thing I am taking 500 watt hour battery is there, the same battery, but I am changing the motor power. The motor is 1000 watts, right? The motor is 1000 watts. Then what will be the run time? How much time it will run? Can you answer? The 500 watt hour motor will supply 500 watts energy for 1 hour, but the motor watts is 1000 watts. It means instead of running for 1 hour, the 500 watt motor will be giving the motor the energy. The motor will run for just 30 minutes. That is half an hour. Only half an hour. Please do remember these basics. This is very, very important. These are very basics. So you should learn so that you can lead the people and you can sell your own electric motorcycle and all. These are the very basics. So why I have not selected the lead acid battery? That we can see. Battery type, capacity, weight, range, miles, lbs, ampere hour. So here is lead acid battery and here is lithium ion battery. See, the lead acid battery I have taken. First see here, range, miles. It will give some miles, means 20 miles, or in kilometers 32 kilometer. Same mileage 32 kilometer. So this is important comparison. See why we are not selecting the lead acid battery for the electric motorcycle for our electric motorcycle. Why means, see, for same mileage, lead acid battery, lithium ion battery, same mileage. If I want 32 kilometers, here also 32 kilometers. What will be the ampere hour capacity needed? Means 15 ampere hour is needed, and here only 9 ampere hour is needed. See, for same mileage, the capacity is varying. We are reducing the capacity in lithium ion battery. It means it will reduce the weight also. 6 lbs here and here 30 lbs. See how much difference. For same mileage, the weight is much reduced for the lithium ion battery, and the ampere hour is also reduced for the cell, that we can arrange to get a battery pack. So this is the main difference why we are eliminating the lead acid battery. So now we are going to see about the how to calculate range of lithium ion battery. For our electric motorcycle. So how to calculate the range? So I already said, so according to the cost of the vehicle, cost consideration, to satisfy the customer need, I will be giving the maximum mileage Then if you want to change, you can change. So what we have taken, according to the motor capacity, motor power only we have to decide. So I am going to decide for running the 72 volt 5000 watts BLDC mid motor. So this is the thing, for this motor only we have decided. So for this, how much battery? 72 volt definitely, and how much watt hour, or we can use the ampere hour also needed. I am going to find out. First thing, in step 1, find out the current in amps consumed by the motor to run. This is important. How much ampere is needed for the motor to run? So we know that power is equal to voltage into current. So what is the power? 5000 watts we have taken. Voltage is 72 volt into current. What is the current? I is equal to 5000 by 72 is equal to 69.44 ampere theoretically. So after if you get some sample motor and battery, you will be testing using multimeter how much ampere it is consuming, amps it is consuming, you can check it. But this one is the theoretical one. This is the step 1, and step 2, you have to find out the watt hour of the battery we need. Step 2, find out the watt hour of the battery. Find out the watt hour of the battery. This is the second step. It means to run 5000 watts motor for 1 hour, simply multiply. It means 5000 watts into 1 hour, you will be getting 5000 watt hour battery. To run the 5000 watts motor for 1 hour, we will be getting 5000 watt hour battery, or 5 kilowatt hour battery. Both are same, but the thing we should consider, what means, so the battery's efficiency may be different. So I am taking efficiency of some 85%, 15% loss we can eliminate that. So it means 5000 watt hour battery divided by 85%, you will be getting 5882 watt hour battery. It means 5.88 kilowatt hour battery we need. 5.88 kilowatt hour battery we need. So if you want to convert, step 3, So if you want to convert into watt hour into ampere hour also, that also you can do, because in commercially available they will be asking watt hour or in ampere hour they will be asking in commercially. So for converting that, we know that power is equal to V into I. It is nothing but power is nothing but watt hour. You can take voltage 72 volt into ampere hour. So watt hour we have found in the previous step, 5.88 kilowatt hour or 5882. So 5882 watt hour equal to 72 into ampere hour. So 582 by 72 will be getting some 81.69 ampere hour. You can take as a 80 ampere hour battery. So therefore to run the 5000 watts motor for 1 hour, we need 72 volt 80 ampere hour lithium ion battery. So this battery will give how much mileage? So I am going to find it in the next step. So keep it in mind this rule: if the electric bike is running at an average speed, it means city drive with normal slopes. So in our vehicle the top speed is 100 kilometer per hour. The average speed will be 50 kilometer per hour. You will be driving at 40 or 30 kilometer per hour, sometimes 70 kilometer per hour, 80 kilometer. So average we have taken. So 36 watt hour lithium ion battery is needed for 1.605 kilometer mileage. See, if I want 1.605 kilometer mileage, see it carefully. If I want 1.605 kilometer mileage, I need 36 watt hour lithium ion battery. 36 watt hour lithium ion battery for 1.605 kilometer mileage. So as your wish, if you want some 100 kilometer mileage, you can select 100 kilometer, 150 kilometer, 200 kilometer, like that. You can select your mileage first, so accordingly you can design. So what I am coming to say is, see this one, 36 watt hour battery will give 1.605 kilometer mileage watt hour. Then what you have found out? what we have found out, this 5882 watt hour battery will give how much mileage, like that we can find 5882 watt hour battery will give 5882 into 1.605 divided by 36, so you will be getting some 262 kilometer mileage. But also apart from electric motor, there were some LED lights, horn, etc. Some more electric loads will be there, so then accordingly the mileage will vary. Then I will be taking that 5882 watt hour, that is 5.88 kilowatt hour battery will give 250 kilometer mileage range. So this one we can arrive, what we have arrived is, so for our electric motorcycle, what are the specifications we have arrived? Top speed of 100 kilometer per hour, weight of 120 kilogram, loading of some 150 kilogram. We need motor type BLDC 72 volt 5 kilowatt motor, battery lithium ion battery 72 volt 80 ampere hour. So these are the things we have arrived. After all these calculations we have arrived for these condition, these constraint assumptions, for these assumptions, so we have arrived very perfectly the motor type 72 volt 5 kilowatt and lithium ion battery of 72 volt 80 ampere hour. So if the battery looks very costly or you cannot achieve the profit, means you can reduce the battery capacity as 72 volt 60 ampere hour or 72 volt 40 ampere hour also you can decide. So the mileage will be, the range will be reduced, that you should keep in mind, the mileage may be get reduced. So far we have completed the battery calculation and motor calculation. Now I am going to design lithium ion battery pack on my own, because the cost of lithium ion battery is more. So if you want a lithium ion battery from some client, you can buy from them, but if you manufacture lithium ion battery pack on your own company, then you can get more profit in electric motor cycle sale, because the lithium ion battery, when we are getting from other company, we cannot give affordable rate, affordable price to the customer of this electric motorcycle. So when you manufacture your lithium ion battery on your own, we can give it to a customer for some affordable price, and also it will be profitable to the company. So that's what we should try to manufacture the lithium ion battery pack on our own in our company. It will be very much good. So how to design of lithium ion battery pack. So theoretically, so this is the basics. So start with the basics theoretically, so that you can do it practically. That we can we can discuss in a separate video if possible, how to manufacture a lithium ion battery pack with the individual lithium ion cells. We can discuss in separate video, we cannot do here. How to design. So if you see the lead acid battery and all, it is available in 12 volt batteries with different ampere hours. So in series connection, in series connection, in parallel connection, both are there. So in parallel connection, voltage is constant, whereas in series, voltage is varying. It means connect the battery in series to get your required voltage. That is, if you want 48 volt, 24 volt, or 12 volt, or 36 volt, or 72 volt, or 96 volt. So these are all the possible thing we can, according to the working voltage of the motor, we can select. So here for this motor we have selected 72 volt. So for a lead acid battery, will be requiring some 4 12 volt batteries. Some 4 12 volt batteries for getting 48 volt. 4 into 12 equal to 48 volt. So for 72 volt, so accordingly we can choose for 72 volt how much battery will be required. So that also should be connected in series, so that we will be getting the 72 volt required volt. So this is the basic. For example, I have taken, this is the basic in series connection, voltage varies, current constant. In parallel connection, voltage constant, current varies. So this is the very basic thing, keep it in mind. So if you want more voltage, the voltage should vary. So for that you should connect series. So if you want ampere hour to increase, you should connect parallel connections. So this is the basic. So with this basic, I am going to design the lithium ion battery pack. So I have taken one lithium ion battery pack. This one. This is plus, this is minus. This is single NMC cell, single NMC cell. So I have taken one example. You have to buy it as a single cell to get the final battery pack. So what are the specifications? So I have chosen some ICR 1865026J Samsung cell or LG, can take anything. Otherwise, if the cost is not permitted, means accordingly you can select. So this is the standard battery lithium ion cell, model 8650. The size is 18650. Rechargeable one. Nominal capacity 2600 milliampere hour. So these are the given in in the cell itself. These are the important thing. Continuous discharge rate 5.2 ampere. Nominal voltage, this is also important. One single cell voltage, nominal voltage is 3.6 volt. 3.6 volt. Dimensions 18.4 mm cross 65 mm. So that's what we can say. 18650 cell model number, because of this dimension only. Approximate weight equal to 45 gram. It means this single cell model is 18650 3.6 volt 2600 milliampere hour equal to, we can take it as 2.6 ampere hour. The weight is, one cell weight is 45 gram. The cell dimensions is 65 mm and the diameter is 18 mm. So these are the dimensions, important dimensions. Single cell voltage is 3.6 volt, but we want 72 volt battery pack. Single cell ampere hour is 2.6 ampere hour, but we want 80 ampere hour, the full battery pack. So I'm going to find out how much cells needed for getting this battery pack with using this only one cell. So we can tabulate. So for understanding purpose only, I'm doing this. So one cell, final battery pack. Voltage ampere hour. Okay, one cell is 3.6 volt and 2.6 ampere hour, but we want 72 volt 80 ampere hour battery pack. So how many cells we need? So number of cells in series. So in series, how many number of cells? To find out this, use the voltage, because the voltage only we are going to vary, because one cell voltage is 3.72 volt. So we want 72 volt. So in series connection the voltage varies, so that I am dividing 72 volt divided by 3.6 volt, it will give 20. Cells in series. 20 cells in series connection will give you 72 volt. It means also number of cells in parallel. So for a parallel connection, in parallel connection the voltage remains constant, the ampere will be changing. So if I want 80 ampere hour by using 2.6 ampere hour cell, how many cell I need? It means 80 by 2.6, 80 divided by 2.6, I will be getting 30.76. So we can take this as 30 cells in parallel connection. So we want 20 individual cells in series connection and 30 cells in parallel connection. Okay, then what will be the total number of cells equal to 20 cross 30 equal to 600 individual cells I need for this, for designing this battery pack. So cost analysis, so we are having some concern, all are trial and error because see the cost of one cell, equal to approximately equal to some rupees 170. Cost of 600 cell equal to 170 into 600, it will give 170 into 600, 1 lakh 2000. 1,02,000 rupees. If you are getting you are not producing one bike, you will be producing some 50 or 100 bikes. So the time you need to buy some 10,000 to 50,000 cells. So accordingly you can contact with the client to reduce the price per cell. If they will be giving it, that Samsung, if they are giving it for some 140 rupees, means for a bulk, you have to buy with a higher quantity of cells, they will be reducing price. That time your total cost will be reduced. But if the cost is not suitable for us, you have to reduce that 80 ampere hour to some 60 or 40 ampere hour. That time the number of cells will be reduced, so that time it will be helpful for you. Then what will be if the battery capacity varies, what is the thing we can compare here? (72 volt, 80 H, 72 volt, 60 Ah, 72 volt, 40 Ah. So we need, for getting battery pack, 600 cells we need. So for getting 72 volt 60 ampere hour battery pack, this will be varying. This 20 cells will be there, 20 cell will be there because of the same, but here the value will be changed to 60. So finally we will be getting 60 divided by 2.6 will be getting 23 cells. So 23 cells into 20 cells will be getting 460 cells. 460 cells. So the cells is reduced. Then if you want 72 volt 40 ampere hour battery pack, how much you will be want? The series connection 20 cells will be there as it is. Here the value will be changing to 40. So 40 divided by 2.66, 15 cells, approximately 15 cells. So 15 into 20, 15 into 20 will be getting 300 cells. So the cost wise analysis, we have 170 rupees. In bulk quantity, if we purchase, take average as 150 rupees or 140 rupees, then 600 into rupees 140 will be taking 460 into rupees 140, 300 into rupees 140. So you will be getting 600 into 140, so 84,000. So 460 into 140 will be getting 64,400. So 300 into 140 will be getting 42,000 rupees, Indian rupees. So if you are reducing the ampere hour, the cells are reduced and the cost is also reduced. Also the 250 kilometer mileage is also reduced, range. So it will be reduced to some low, and this will be reduced to low. Mileage calculation you can see. So accordingly you can choose the battery pack according to the mileage requirement of the customer, or mileage requirement you select in your company. Accordingly you can select, so that you can reduce the cost. If you are getting this whole battery pack in some other company, the cost will be increased. If you will be buying these cells and do it on your own battery pack in your company itself, then the cost will be reduced. So best option is to manufacture your battery pack in your company itself. It is the best option. Then what will be the weight of the total battery pack? One cell weight is 45 gram. Total battery pack will be some 600 cells I have taken for a 80 ampere hour calculation. So if you need 60 ampere hour, you can change, or 40 you can change, 20 also you can change, but the mileage will be reduced accordingly. The range will be reduced. So here 600 cells I have taken into 45 gram. So the total battery pack weight is 27 kilogram. So with BMS, battery, cover, case, so approximately you can take 30 kilogram battery pack. Okay, so battery dimension, regarding the battery dimension, so battery dimension, if you will be arranging in a rectangular format or a triangular format, final battery pack dimension according to the bike chase requirement, whether to provide like this battery pack or some triangle shape battery pack. So according to the bike chase you can design something to hold this bike frame or something like this. So this design, according to a chase's design, you can design, but what is the basic thing of arrangement I will be saying now. So I have said already the arrangement, basic cell arrangement, mm, 20 cells in parallel series, 30 cells in parallel, 20, 30. Cells, 30 cells. So I am taking red color for positive 20 cells in series. Series parallel. So this is the basic arrangement you can arrange. Otherwise, according to the chase design, you can do. So this one, 20 cells in series plus so in series means plus minus plus minus. So this is series connection, plus and minus are series. Series means plus and minus you have to connect. So parallel means plus and plus, minus and minus you have to connect. For getting the ampere hour, variable ampere hour, will be using like this. Then here 30 cells in parallel means, so here 1 2 3, so like this. 30 cells. So in this 20 cells. So here also one is missing, 20 cells. So here according to this one will increase. So like this. So you can fill here also. You can arrange for electric rickshaws and electric car and all, this will be good. I think for a electric bike only this arrangement may suit or may not. So according to that chase design, you can do battery pack at one at the bottom and one at the top. That also, that arrangement also you can do, that we can see practically. Like this arrangement you can fill. So you can fill it with, so 20 cells in the series and 30 cells in parallel. You can fill like this, and you can weld it with, you need nickel strips for welding. So soldering machine. So if one cell is here like this, this is plus minus plus. So you can weld here like this. So this is some 3.6 volt. This is also 3.6 volt. It is series connection, plus and minus. Series means plus and minus, series connection. Then the output voltage will be measuring in multimeter as 3.6 plus 3.6 equal to 7.2 volt. So this is the basics, and after in some occasions we can do it practically. We can cover some videos and we'll do that also. So regarding the BMS, battery management system. Battery management system also, it is very important. It is essential in lithium ion battery, very much essential for safety purpose. This device manages a real-time control of each cell, because when we are recharging the battery, some cells may be in out of 600 cells, some cells may be fully charged with 3.6 volt, some only reduced to 3.0 or 2.9, 2.7 like that. So for giving those cell is in need to recharge, this will be real time, in real time control each of the cell and communicates with external devices. So it will manage SOC calculation, I mean state of charge. This is also state of charge is also an important thing for a battery. It will measures temperature, this is very much important, and voltage, temperature and voltage. These are the functions of battery management system. And why it is much more important means the choice of BMS will be determining the quality and lifespan of final battery pack. So for safety features nowadays they are using this because it should not explode. The lithium ion battery, when it heats up, it has tendency to heat up and explode. So for safety purpose also, and also if the charge full voltage battery cell is 3.6, the charge full, if it is in full charge, then again you are charging means then the life will be reduced, so that this BMS is real time work with the state of charge calculation, measures the temperature, measures the voltage, and it will be decide the quality and lifespan of the final battery pack. So next important thing in the overview, you'll be see what are the things we have covered. So we have found the motor power calculation, motor speed, selection of motor also we have done, selection of battery capacity calculation, battery design with BMS. It is discussed only in small content and theoretically. The practically we can do it in some other videos. Then finally the 10th, the last and final, the charging time and current required for this battery we are going to find. Then after that we can produce a prototype, test it, and what are the things we need to design, that and all we can discuss in the next series of video. So how to calculate the charging current and charging time required T to recharge the lithium ion battery. So before that, be cautious, please be cautious. Why we are calculating this? To increase the safety, because we need to find out the charging current, correct charging current required and the correct charging time, so that it will be very safe, and also to increase the life of battery, also we are doing this. So kind advice, don't try to design your own battery charger unless you are expert. Okay, please don't try to design your own battery charger unless you are an expert. But for the specification, we need to provide the details, so that we'll be telling the customer this much charging time it will take to get 100% charge, like that. Or we can buy the battery charger from battery manufacturer, or you should learn to become a good expert in designing this charger. That is also not a big thing, you can confidently do after having some practical experiences. So there are 4 steps to find out the charging current and charging time required. Step 1, please note down the battery capacity in ampere hour. If the battery capacity is specified in kilowatt hour, convert it into ampere hour. Okay. Step 2, calculate the charging current required by using this hint, that is, the hint is charging current IC of lithium ion battery should not exceed 30% of ampere hour rating. Mm, 10% you can use for lead acid battery, 30% for lithium ion battery. So because of both chemistry are different, you can take 30%. I mean, the charging current IC is should not exceed 30% of ampere hour rating of the battery pack. Keep it in mind, this one. Then third step, calculate the charging time in hours by using the formula charging time TC equal to battery capacity in ampere hour divided by charging current in ampere. Then fourth step is consider some 30% of losses during charging of battery. So this is because why we are considering some 30% of losses during charging. So while the charger will be connecting by using the battery charger, the battery pack, this is the battery charger, due to heating effect of current, so due to heat dissipation, there will be some losses. So I am considering 30% of losses for finding out the charging current. So for our lithium ion battery pack, I am going to find out. So our lithium ion battery is 72 volt 80 ampere hour battery. So I am going to calculate the first step. The first step is if in commercially it is given in kilowatt hour, means convert it into ampere hour. I have noted down the first step. The second step is the charging current. The charging current IC equal to 30% of ampere hour for lithium ion battery and 10% for lead acid battery, equal to 0.30 into 80 ampere hour. You will be getting 24 ampere. I see 24 ampere. This is the charging current needed. Then I am going to find out the charging time. Charging time Tc is equal to battery capacity in ampere hour divided by charging current in ampere. You'll be getting charging time in hours. So battery capacity 80Ah. If you want 60Ah, 60, 40Ah means 40 divided by the charging current we have found 24 equal to 3.33 hours. So this is the in ideal condition. In perfectly designed, this is not possible. There will be some losses. Due to that losses, the battery will take some extra time to recharge itself to get 100% charged. So that I have taken some 30% losses, that is due to heat dissipation losses. 30% time will be extra taken to charge the battery. So Tc is 3.33 hours. Then extra time 30% of 3.33 is 0.99 hours. So you will be getting 4.32 hours. So Tc will be 4 hours 19 minutes to get 100% charge. This is the required charging time we have got. So what are the specifications we have got? I am going to tabulate it. Specifications. Number 1, electric motorcycle specification. So the vehicle performance top speed 100 km/h, acceleration or pickup 0 to 100 km/h, it will take 10 seconds acceleration. Then we want motor spec, voltage 72 volt or some 48 to 72 volt working voltage you can take. Rated power 5 kilowatt, peak power 10 kilowatt, speed of motor will be some 3000 to 5000 rpm. Rated torque 10.62 Newton meter, peak torque 21.24 Newton meter, and efficiency equal to some 85 to 90%. These are the motor specifications. Then regarding the here also you can add that motor is motor type you can take BLDZ mid motor. Then battery specs, battery specification if you take means voltage 72 volt, capacity 5.88 kilowatt hour or 80 ampere hour. Both terminologies can be used. Range, this battery pack will give you the range of 250 km per single charge. Charging current 24 ampere. Charging time 4 hours 19 minutes. These are the theoretical calculation, then we can do it practically and check it. Charger, we can have some 15 amp charger or 10 ampere charger, that also we can use. So for ARAI approval, I have told, so you have to fill up application for ARAI. Fill up the application. Official will call you for the vehicle test. So before that, some two procedures will be followed. Two procedures. One is nodal agency, another one is test agency. So here your application form will be verified, then only it will be passed to the test agency. It will take some 3 months to get approval, with the overall cost of some about 10 to 15 lakhs charge for the test by ARAI. So next part we will discuss about other design of motorcycle. Thank you.